Okay, we are continuing on the PBX adventure. These are Kofi videos. It's a Kofi video series on PBX Research, and then this will culminate in a consolidated video with all the findings from it, right? I don't know how many videos it's going to be. We're just going day by day by day. So what do we have so far? Well, we probed 4 materials. One of them looks ready to move on to EM loading. The other 3 are still in development. We're continuing off the last day here. Both the Cashmaster rat glue formulation to work on. We've got the PIB being dissolved, and then we've got to decide what to do with the EVA. So I guess let's just look at the progress of where this is. I haven't been out here in the lab. This stuff's been sitting overnight. So we're now out here. It's been over 12 hours. We're going to look and see the condition of everything. Okay, so the PIB is definitely dissolved. It's now a gelatinous half sphere. It's a bubble. It's a parabola of gelatinous PIB in the toluene. So toluene does dissolve it, and the trick was just getting this, the particle size small enough to let the toluene do its work. The way that looks is the way that I feel all the time. Okay, but seriously, so I guess we got to decide what to do. What did I say on these notes? What am I going to do with these? We're going to do... Okay, so for PIB, I think, we've got a couple of options here, right? We've got the actual PIB. This is going to be the closest to, what people would expect from C4. In order to really do it properly, we'd have to do the actual wet method because we're using a solvent, we can't really do that. For one thing, I do have some stuff, like we could degas, but I just don't want to mess with that because I don't really know what I'm doing to judge it. I feel like I could waste a bunch of time. And I don't even know if my vacuum's, pull enough. So I think what we ought to do with this PIB is, right now this is just PIB with toluene mixed in there. I think we ought to add the DOA plasticizer, and then I think what we'll do is just hand mix in some petin, which is very dangerous, but I think that's what we're going to do, make a petin charge with PIB, because this one's, the PIB formulation is already known. We'll just go ahead and skip any kind of inert simulant and go straight into a petin charge that we can detonate. Hopefully it's understood that, I don't advocate you guys doing this. This is there's definite risk here in terms of just using like a solvent with we're not even going to dilute the petin. I'm gonna mix in petin in here, and I'm gonna take some precautions, like wear ballistic armor, things like that. I'll probably switch it over to a plastic container instead of using a glass container for shrapnel. So I'm going to take some safety precautions, but just understand that this is not a safe, method of producing PBX, but this is the most direct way without going into the full steps of the way that you would actually make a pressable powder with polymer coated RDX particulate, and then press the thing and then degas it, under high vacuum. I'm not going to try to do that. We're just going to do what, a person would do in their own, home lab if they were trying to make a moldable plastic explosive. Before we do that, let's just take a look at everything else where we're at here. EVA. Okay, so we got the EVA here, and okay. It's definitely soft. It's got some polymer. You can feel the polymer give. And it's definitely pressable. So this is like, I could press this and it's going to stay consolidated. It's not, it's not moldable like a putty or something like that, but you could definitely press this. So it's almost like a crumbly consistency that can then be pressed and retain some shape. So this is interesting. I guess what this does is, I think this means that EVA is valid. You just have to find a formulation. So, we could spend a lot of time on EVA figuring this out. I feel like maybe we'll move and knock out some of the others that are quicker and then return to EVA. Because this is definitely, like, we can fine tune this and get something that's pretty interesting, I think. definitely way more usable than any of the other tests. So I think we're getting somewhere on here. This is, moderate progress. So let's put this one on the back burner. We'll just annotate everything that happened with these first tests, and then we'll return to it after we eliminate some of the other, or complete rather, some of the other PBXs that we'll be able to go through into energetic PBXs with. Okay, moving on to the last one here. We've got the Catchmaster rat glue. So this is totally dissolved. The amount of solvent that we used in here, it was I can't remember, 10 grams. I've been doing pretty much 10 or 15 grams across the board. So I think it's 10 is what we did. So this just sat here. There was no heat and there was no mixing. This just sat overnight. So this is a liquid, and the rat glue is totally dissolved in there. Okay, so let's try to take the foil out and see how that goes. I'm just going to grab the edge of this foil and kind of wiggle it, drip it. I mean, that appears to be a pretty good method. It seems like it works well. I mean, there's probably a marginal, amount. There's probably a very small amount of polymer still on this foil, but it's not much. I mean, most of it is going to be in this. I'll shake it just to make sure everything gets off. There we go. I'm happy with that. So everything else in here, this liquid, this should be, most of that polymer. Catchmaster system, don't know what to expect. Let's see what I put in notes. I intended to do, to try to emulate the PIB formulation, but with the rat glue. Now the rat glue is, the Catchmaster is very squishy and soft, and when you put it in some solvent, it just becomes completely liquid. So I don't know if, it could be that the DOA is going to be, it's going to make it too mobile, and it won't be stiff enough. But we're just going to start there with that formulation and then work our way around that. Let's attack this first, and we're going to make an inert simulant with this one. And let's just use, we'll use melamine so that it's a powder. So we're not getting anything weird from the morphology of granular sugar. But let's see if we can get something usable off of melamine. 3.1. Dang it, 3.3. It really comes out of there quickly. All right, I just added the DOA in here. 3 grams was the DOA load, and I didn't have my headset on, so I'm just telling you what I did now that I got the headset on. So it's all in there. This is both polymer and plasticizer. And now we would add 1.6% mineral oil. I'm kind of afraid to do that because this is almost too wet already. So we're just going to go ahead and do it just to see what happens here. All right, this is going to be a, what is this? 1.6% mineral oil, which is only 0.90 grams. So not very much. Not very much at all. Mineral oil is pretty sticky. A little bit more viscous than the DOA. 3. Man, it really doesn't like to even exit. 0.95. Okay, close enough. It's fine. Now we're gonna try to add this to the mix. Some of it, a couple drops won't get in there, so maybe we'll get rid of that unnecessary milligrams that we didn't need. Okay, there we go. The mix. Can you see the light distortion going on in there? It's like wavy, oily mixes. So I'm gonna put this on stirring for a minute. All right, let's turn on some stirring. We'll stir it up for a minute, and then we'll add in a melamine fill. Oh, that's a little high RPM. I don't think we need to stir that fast. Good to go. Okay, we'll get some melamine ready. Okay, I got the Catchmaster, a little bit of heat, and it's been stirring for a bit, so it's probably pretty well mixed up. We got the filler. It's a 91% filler, which is, that's quite a fill, but we're just going to start there and then work our way back. So here goes a little bit of melamine. We've got 51 grams of melamine going in here. Mixing up nicely. quick. It's going in quickly. I got to remember not to breathe too hard because like this, I mean, I'm not making any noise with my breath, but through the microphone it sounds like you gotta remember. Just hold my breath. Okay. Just move this around a little bit, get this stuff all mixed up in here. Starting to slow down on the stirring, so this is getting pretty thick now. Remove the stir bar, and then we're going to go into manual mixing and processing. Man, that melamine just drops right out of there. It's on the bottom, coating the glass. I don't know, can you see that? It's coating the glass. That's all right. That's just what we're dealing with. So, kill heat, kill stirring. I'm just going to hand stir some in here and then use a PTFE rod to mix it up a little bit. Got so much melamine to add. We're nowhere near complete by any means, and this is getting thick. Okay. Wow. Maybe this is why a lot of these rat glue formulations have to have high rat glue content, just to be able to bind this all together. Well, darn it. Yeah, I don't think that's going to work. I mean, we've got a whole lot more melamine to go in there, and this is already look, it just rolls powdery. It was looking pretty good at like 5 grams of melamine. All right, I went ahead and stopped adding melamine. Just there's no reason to waste it. It was obviously not going to be working at those proportions with the Catchmaster glue. Remainder, I had 22 grams left over, so about 29 grams went into this mix, and I'll show you what that mix looks like. It's similar to other ones with like EVA, so this would be a sign of it not consolidating, not having enough polymer bonder ratio. And I think the rat glue has to be a substantially higher ratio to be able to bind this stuff, because this is just not gonna work. It will not do. No, sir. Now we'll get to contrast the Catchmaster with actual PIB and see what the difference is. We're going to add some plasticizer to the PIB. Let's see. So what do we want to put in here? We want to put 3.15 grams of plasticizer. There we go. We did it. Great job, team. That's a lie. It's not 3.2, it's 3.1. I saw it. I put it in there. I was counting it while I was dropping it. Okay, back on stirring here. We'll mix that up. We're going to be able to get... yeah, there we go. Okay, so it's spinning again. Mixing it up. Let's add some heat too. Warm it up. It's been off heat because it was sitting here overnight and I didn't want to blow off all the toluene overnight, so... We'll put some heat back on, warm it up so it gets well mixed and heated, and then we'll... oh, shoot. You know what? I didn't put any mineral oil. Let's put some mineral oil in there. Shucks sakes, guys. I can't believe you weren't even going to tell me that I left out the mineral oil. You're just going to let me carry on like everything was fine. I was counting on you. Really disappointed more than anything. Okay, let's clear this out. Got the scale cleared out. What are we going to put in here? Mineral oil, PIB, oil, 0.97. Okay, sure. Why not? 0.97. So I don't even know if we'll be able to get that kind of resolution on here. We'll try. Oh, there we go. Okay. That's probably actually pretty close to 0.97. Bounce to 10 and then back. That's a good sign that it's favoring higher 9. We got our mix. Let's put it back on stirring and heat. Really gelatinous. Got to heat it up. Got to get that broken down. We may have to add some additional solvent, because that is not liquefied near enough. Okay, here's the situation. We've got the PIB. It's thick and globulous in there. There's a nice ball of PIB there, all melted. This is probably too thick, so we're gonna add. I'm gonna add an additional 5 grams. We'll do 5 grams of toluene, and then if that's not enough, then we'll go to 10 grams. All right, 5 grams of toluene have been added. We're gonna mix it up. Yeah, that looks much thinner. Okay, good. So the second thing is that originally I was going to do an energetic filler. I don't really feel like whipping it up and then blowing it. So I'm going to hold off. I think I'm getting carried away and getting ahead of myself with, jumping to the conclusion that this is just going to be good to go. I have a feeling it might not play out like that. So let's just keep it simple, stupid, and we're just going to put some sugar in there. If we put sugar in there, we'll get an approximate idea for what we're going to be looking at. We've got PIB, so we can, if it's successful, if everything looks good, then we can go ahead and use the energetic filler. But if we don't need to, if this thing is going to be another jacked up PBX attempt, we don't want to waste that, right? Because I'm just going to have to detonate a bunch of stupid pen that isn't even right. But if we do sugar, then not only do I not have to detonate anything, but I also don't have to get dressed up or anything like that. We're just pouring some sugar. So let's do that. Okay, 91% sugar filler. Here we go. Got some chunks in here. Probably crush those up. All right, here we go. This is pretty cool. You guys like my science project? That's pretty cool. Fun to look at. I enjoy it. All right, it's getting pretty thick, so I'm going to pull it off and pull out the stir bar, and then we're going to, I got melamine everywhere. Let's get the stir bar out while we still can. My goodness, that is one sticky stir bar. Okay. Trying to get the PIB off there. Good enough, I guess. My goodness, that is sticky. Sticky, sticky, sticky. Messy, messy, messy. Wow. Wow, looking pretty good so far here on a 91% filler. This looks good. This is almost like when we were doing the polystyrene, and you could just tell when you put the filler in there. You could just tell that things were happening. It's kind of like what's going on here. We got some things happening here. They're happening well. Signs of success. Can you even see this? I don't even know if you can see this. Sorry about that if you couldn't see. I wasn't monitoring the phone. Man, this is definitely in its own nature, its own class of stickiness. Much stickier than everything else that's been used so far. And of course, it's pretty, it's very mobile, because we have a lot of solvent. We just added additional 5 grams of toluene to make it more of a liquid. So this has a lot of solvent to evaporate off. So we'll just mix it. I'm going to get off camera and mix it here pretty thoroughly by hand, and then we're going to put it on the hot plate. Totally different than everything else so far. Can you even see that? Here, maybe I'll move around so you can see better. It's just really different. We'll get this solvent burned off, and then get a handle on this and see what it looks like. Okay, let's spread this out a little bit. Very wet. I'm going to assume that's a good sign. I mean, it's not crumbly at all. It wouldn't be crumbly. All right, we'll let that dry. Okay, so we've got some conclusions here. Of all the materials, EVA, we're going to put it on the back burner and come back to it. We're going to try to get the rag glue and the PIB down. The polystyrene's already good to go, so we're just going to blow that up when we have some other stuff to blow up. The PI formulation looks pretty good while it's wet, so we're drying that out. We'll dry it out and see what it looks like when it's dry. The rag glue formulation was no good, so we're going to reapproach that. I think the next step to it will be to go high rag glue content and a high filler content at the expense of the DOA and the mineral oil. So this will let us bracket, we'll begin to be able to bracket. So we'll do the exact same thing as before, put some Catchmaster dissolved in toluene and add mineral oil and DOA. But the proportions are going to be, we'll just do 8% glue and 1% each of DOA and mineral oil. So that's taking the fill. We're taking the total fill down to 90% just so we get a whole 10 percentage points to play with here. But an 8% glue content will be, that's a lot higher than what did we do in the last one, 2.1%, which is not much. So we'll go up to 8% and see how this affects the mix and start to narrow down what sort of properties each of these materials give the physical handling of the product.